In this video, I'm going to talk about a supplemental activity you can do with Unit 7, Day 5, Lesson 3A, Squares and Equations. This activity is something you can do within your classroom to really foster a deeper conversation around perfect squares and the idea around the fact that a square root always has two answers, a positive and a negative, and you can never square a number and get a negative answer. And these are some big points because when students don't understand this idea or concept, they will then struggle a lot when solving quadratic equations and make tiny mistakes when square rooting and squaring numbers. Okay, so the first question is really simple. What is the area of this square? Explain your reasoning. And so you'll have students respond things. The area is 9 because 3 times 3 is 9. The area is 9 because to find the area, you multiply length by width. The area is 9 because 3 squared equals 9. Interesting. So 3 times 3 and 3 squared. Two ways of writing the same thing. 3 to the second power represents 3 multiplied by itself 2 times. Why is it called squaring a number? Well, when we hear square a number, we're really thinking about multiplying the lengths of a square. That's why we call it squaring a number. In this situation, the student who wrote 6 may have been confused about how to find area. So based on what students write here, I wouldn't have had this to start with. Depending on my student's level, I might not have this information here, but I might add it in as we're discussing. How do you find area? Length times width. What about area of a square? Well, it's the same number, so I can just square the side. Okay, so now that gives a nice little refresher of just how to find area and what does it mean to square a number. So what are possible values of p and q that make this equation true? And so we have students writing p equals -2 and q equals 4. P equals 1/2 and q equals 1/4. Interesting. So when we square a fraction, what happens to the answer? It becomes smaller. Interesting. Let's look over here. P equals 5 and q equals 25, and P equals -5 and q equals 25. How does q equal the same thing, but P is different? Well, we know a positive times a positive always equals a positive, and a negative times a negative always equals a positive. So P can have two different values to give me the same q. I can have two different inputs that give me the same output. Interesting. Maybe you can even ask, is that a function then? It is a function because the inputs cannot repeat, but the outputs can repeat. Each input still has exactly one output. Let's look here. P equals -3 and q equals 9. Can you explain how you got that answer, you might ask? Oh, well, -3, when I put it into the calculator, -3 to the second power says it's -9. Interesting. But is it? What do you know about a negative times a negative? It's a positive. Why is the calculator telling me this? The calculator is telling you this because the calculator thinks you're saying the opposite of 3 squared. So what you have to do when you enter this into the calculator is you have to put parentheses around that negative. That's going to give you the actual answer of +9. So be really careful with this because this is a common error students make. Just letting students know that. Okay, so we had a conversation about this one. What are possible values of p and q that make this equation not true? Okay, so we have some things like 2 and 6, right? We obviously know 2 times 2 is not 6. Interesting, 4 and 15. Well, 4 times 4 would be 16. And you can have students explain why this does not make it true. And somebody else, not the person who wrote it, explain why this is not true. Well, I know a positive times a positive is a positive, not a negative. What about here? Why is this not true? Well, I know a negative times a negative is a positive, so that -10 squared would have to be +100. Interesting. So let's think about this. Can q ever be negative? Can p be negative? And that's the next question. Is it possible for p to be negative? Yes, p can be negative. We saw a bunch of examples. -4 to the second power gives me +16. This person said, no, p can't be negative because a square can't have a negative side length. Interesting. So you're talking about a context of a problem when we're talking about finding area. In that case, that would be true. But because we're talking about an abstract equation, we can actually square negative numbers. Negative numbers are allowed to be squared. Is it possible for q to be negative? Can I ever put a number here and get a negative outcome? What about a fraction? What about a decimal? What about a negative number? No, there's no possibility. You can never square, and there is no number you can square that will give you a negative. Why? Because a positive times a positive will always be positive, and a negative times a negative will always be positive, and p has to be the same number to square it. Okay, and you want to give students the opportunity to have that conversation, to justify and explain why, to add on, to give examples. You want to facilitate a space for students to talk about this so that when they leave this lesson, they understand that Q cannot be negative and that P can be positive or negative. Okay, so when we have what is the solution to this equation, what we want to drive out by this point is that students are saying 3 and negative 3, right? And a student who says 3, we might say, why? Is there more than one solution here? Yes. Why? Because there are two possible numbers we can square to get 9, 3 and negative 3. We are used to only thinking of positive perfect squares. Now that we're in Algebra 1, we're also thinking about that negative square root as well. Okay, so negative 3 squared also gives me 9. So every time you're solving an equation like this, you're going to have two answers. The positive value that gets squared and the negative value that gets squared. Okay, great. And so that's kind of wraps up this activity. You have a lot of options of how you facilitate this. You can pick and choose certain slides. You can allow students to work on this ahead of time. You can allow them to work on it in the moment, slide by slide. But you really just want to drive home the idea of the fact that when you square root a number, you get a positive and a negative answer, and you can never have a number squared equal a negative. If students understand that, they're going to be a lot more successful when solving quadratic equations algebraically in this unit, and it will avoid those tiny mistakes that students often make when square rooting numbers.